Let me see. So if the graph changes from concave downward to concave upward, that is the point of inflection, or the other way? We're stuck somewhere, like you were saying mod sin x. So what are your answer? Is it a point of inflection? Where is But there is one thing, every time the point we consider the function is continuous, right? So what happens here at the mod sin x? You are coming up with some explanations, some of you. Yes? Last class you were saying, no, what happened? Is it a point of inflection for those points?
Yes, ma'am, this is a point of inflection.
And some have doubt that it's not a point of inflection.
No, ma'am, all
Ma'am,
doubts
the
are cleared.
concavity, ma'am, the concavity is same on both the sides, so it should not be the point of inflection.
So what should we do? So at point n pi, it's continuous or not? It's not continuous, no?
I'm continuous, not differentiable.
Not differentiable. So what we say about the, if you look at the tangent, if you look at this, the curve looks same, but the tangents, are not they changing the sign?
Ma'am, the sign of f double dash of x on both the sides of the point is same. That's why it should not be the point of inflection.
What is
Yes,
f double
ma'am.
dash x?
Ma'am,
How
the
much?
Ma'am,
sign
the
is
tangent is moving anti-clockwise only.
Uh,
Sorry, clockwise only.
Clockwise. Yeah, it's moving clockwise only. So, and the one who is saying, what is your view here? It's moving clockwise, right? Both cases. And what about the, what is f double dash x? You are saying, no? Let's come to our definition.
ma'am, it
F
is
double dash.
f double dash of x is negative on both the sides of the point.
It's negative, both sides of the point.
Yes,
Yes,
ma'am,
ma'am.
it's not changing sign.
So then it won't be a point of inflection. Okay, so it won't be a point of inflection then.
Yes, ma'am.
If both the sides we have, is it negative or positive, the double dash x?
It is the negative, ma'am.
Negative, ma'am.
Negative, ma'am.
Okay, so here, so f double dash x is negative on both sides of n pi. That's all the points. Okay, so it's not a point of inflection. So here, so we'll write not a point of inflection. So we will look at our definition. Okay, tangent is moving its clockwise, and what we said. Okay, on both sides we have negative Even point where you are finding at point on the curve. Okay. So, normally if you look at the where they use curvature, if you look at the railway tracks, okay. So the railway tracks while bending, like how much possible bending is there? Okay, whenever it's there is a curve, when straight there is nothing to do worried, but rail, like how much curvature? Okay, the maximum possible curvature that they use there. Okay, while laying curved railway tracks. Okay, this is one of the applications they used. Okay, so let's see now. So, and also if you look at the shape of a curve, it's characterized by the degree of bentness or degree of curvedness. Okay, so a straight line, if you say, has no bending. Okay, so a straight line has no bending. So you can say it is having curvature 0. Okay, so that straight line has curvature 0. Can you say like this? Is it wrong or is it okay? And if you look at the circle, it has constant bending. These are the type of curves. Okay, circle has constant bending. That means it will have constant curvature at any point of the circle. You will be getting same curvature. At all points of the circle, we have the same curvature. Curvature is same. Okay. You can also say, as you said, curvature of a curve is a measure of rate of change of bendness. Okay. And here also we define a term angle of contingence. Okay. You may not find it. Okay. You can we have the direct formulas. We can use them and we can find the curvature. Okay. For different forms also we have derived. Okay. One for Cartesian form, parametric form. Okay. So here, so if you look at the curve where it is like the arc with greater angle of contingence, okay, that means curvature is more there. It's more curved, then curvature is more. Okay, you have two arcs of same length, and one of the arc with a greater angle of contingence is said to have more curved or have more curvature. Okay, so if you find average curvature of an arc AB, then what you do, you just divide the angle of contingence by length of the arc. Okay, let me show you that. Angle of contingence. Of the arc AB. Of curve C. See, if you remember directly, I will tell you this formula. Is the angle between the tangents. Is the angle between the tangents. At A and B. So to the curve C. Okay. So the point A, and this is the point B. So we have this our tangents. So here we have this is alpha, and this much is delta alpha. Okay, the tangent at A and tangent at B, that makes the angle delta alpha. Then this much angle is alpha plus delta alpha. Okay, so delta alpha is the angle made by the tangents to the curve AB at the points AB. Okay. Now, given two arcs of the same length, the arc with the greater angle of contingence is said to be more curved. Okay. Now, average curvature of an arc AB is of an arc AB is so angle of contingence by length of the arc AB. Okay. So here you can say this is the angle of contingence delta alpha by the arc AB. Okay, this is your average curvature. Okay. So we have the formulas. Okay, curvature of a curve at a point A is denoted by K, while limit B approaches to A. Okay, so this K you can say let's say it as kind of A, B. So here K will be limit curvature at a given point. So if A approaches to B, or yeah, okay, so this will be okay. So it's a limiting situation. So what we will have is this is d alpha by d. S is the arc length and alpha here del alpha. So limiting situation. So this K is the curvature at point A. Okay, this is how. Okay, so this is the definition. So now I'll give you directly the formula, the Cartesian form. So a curvature of the straight line. Let me give you a calculation of curvature. So if you have the Cartesian form and the curve, the equation of the curve is y equals to fx. Y equals to fx. So here we have y1 will be dy by dx and y2 will be the second order derivative. Okay. So let me write here y1 dy by dx and y2 is the second order derivative. Okay. y is fx, y1, y2. Then alpha will be tan inverse dy by dx. Okay. So tan alpha equals to y1. So alpha will be tan inverse y1 and that is dy by dx. Okay, so these are the terms I'm telling you. Tan inverse y1, then d alpha by dx. So d alpha by dx will be 1 by 1 plus y1 square. So y2 is the second order derivative. So ds by dx will be, see from here you can see k is d alpha by ds. So here we have d alpha by dx and what we need is dx by ds. Okay. So dx by ds. Okay, now then we will divide it. So k is d alpha by ds. Curvature d alpha by dx. So if you further simplify, we have this y2 by 1 plus y1 square or 3 by 2.
Ma'am, what is S here?
S is the arc length. Okay, I didn't write
Okay.
S is the arc length. Okay. So y2 by 1 plus y1 square 3 by 2 and we will go for the absolute value. So this is the curvature and we can also write it the dx dy form. Okay. So that means y2 is d2 the second order derivative and here this y1 it's dx by dy. Okay.
So it should be 1 plus y1 to the power whole square whole to the power 1 by 2.
1 by 2 d alpha k equals to d alpha by dx ds. Okay. It's not 1 by 2 but if it is d alpha by ds so it will be this is how. Now if you substitute what happens, y2 divided by 1 plus y1 square and here dx by d this is 1 plus y.
Ma'am, it should be d alpha by dx into dx into by into dx by
Ma'am,
ds.
d alpha by
ds by
Into,
dx
in, it
ds
should be
by
into.
dx. Okay, okay. ds by dx. The chain rule you are talking about. You can also write this way. We are dividing dx. So this one and this ds by dx square, what you will have here. So we have dx. So if you write the same thing, it will be the multiplied by dx by ds. So it will be. And here 1 by 1 plus y1 square. So here k y2 by 1 plus Okay, and we will go for the absolute value, that is positive value. Okay, and there is one particular thing also you have to take care.
Ma'am,
Yes.
Ma'am, dx by dx
dx by
equal to how?
ds, it should, it will
Other,
be,
you,
Ma'am,
yes,
it will be
dx by dx.
multiplied. Ma'am,
Okay,
the
you can
power will.
also write multiply. It's the same thing.
No, ma'am, no, ma'am.
No,
After
ma'am.
that.
How dx by ds equal to 1 plus 1? This dx by ds
I
equal
think
to
it should
root over
be,
of 1 plus y1 square.
Wait. What you said?
Ma'am, how dx by ds equal to root over of 1 plus y1 whole square? That
So
one.
what is dx by ds? ds by dx is 1 plus what is y1?
Slope
dy
divided
by
by
dx.
Is equal to root
So
1 plus y1.
1 plus y1 square ds by dx 1 plus y1 square root. So what you are getting? S is the arc length. Okay, ds by dx. X is the axis, x-axis. So with respect to x, how it is changing? ds by dx. So you look at this
Ma'am, once you say dx by dx, how dx by dx equal to root 1 plus y1 square?
1 plus y was square root of 1 plus y1 square. Okay, wait a
Yes,
minute.
ma'am.
It's the arc length. Okay, arc length you don't know that part. Coming. So if you look at that diagram, one plus dy by dx whole square under root. This is the S is the arc length and that of which limiting condition ds by dx.
Ma'am, that was studied in a projection of tangent.
Yeah, I got it. Projection of tangent. I look at that curve. Not this one. So dy by dx, we will be getting the slope and this length ds by dx. Again, where I am. This is simply the length of arc we are getting by this. But just a minute. One y1 square. But how I will say that? So this curve is y equals to fx. Okay, so dy by dx is the, suppose the point. Okay, and yeah, the curve if you join, then we will be getting bigger one. So dx by ds, what it represents? Dx by ds, what it represents? Dx by ds.
It should be ds by dx equal to 1 by 1 equal to here d here it should be ds by dx equal to 1 plus 1 y1 also.
ds by dx equals to this much we have written here. No?
Ma'am,
Okay, I have written wrong.
here you have written
Okay. This one I made it so.
Now this can be proved, ma'am, by Pythagoras diagram.
By Pythagoras theorem, here you will be doing the triangle. You make it, and you will be getting. So this one I have changed. This is
Yes,
what you are
ma'am.
asking.
Yes, ma'am, this was wrong. Yes, by this I was confused.
Okay. So now is it okay?
Yes, ma'am. Now it's okay.
Only this one. This part you are
Yes,
talking
ma'am.
about. Okay.
Yes, ma'am. This was wrong.
Okay. So where we are, okay. Now we will look. If you consider the straight line, whether you are getting what is your curvature you are getting, you can check one example. Then we will go for the other forms. Okay. So if you have this straight line, so what is the equation for straight line? Let's say y equals to mx plus c. Okay. So example y equals to mx plus c, and we will find the curvature. What will be y1? M. Y2? Y2 is 0.
0.
So K we are getting as 0.
0.
So this is the curvature. So it's a straight. Like we know it's a having 0 curvature, but we are checking. Okay. So we are done with the Cartesian form. Now we will come to the polar form. And first the parametric form. There is one particular instance also. If your like tangent is perpendicular to x-axis, what happens? What we will do? Okay, when tangent is perpendicular to x-axis.
It's
Okay,
equal to K.
x equals to k. So what happens? Y1 will be 0. Dx by dy is 0. And dy by dx will be how much? Slope dy by dx. Perpendicular to
Ma'am, y1
x-axis.
will be 1.
Y1 will be 1.
Y1 will be 1.
Y1 will be 1. Dy by
Yes.
dx.
And
Why? Y is
No, ma'am,
x.
infinity.
So
It should be
And
infinity.
tan 0. Tan 90 degree.
it's
Infinity
infinity.
it will be.
It's infinity. Why 1? For y equals to x, it's 1. Y equals dy by dx is infinity. So here dx by dy will be 0. Okay. So we will try to use this form. Okay. Change it to this form. X equals to f of y. So this is one simple idea you can use. Okay. And in that case, you can write just the opposite. And here k will be dx by dy formula. So instead of dy, we will have this one square, and in the denominator, we will make it 1 plus dx by dy. Obviously, square. This is 3 by 2. Okay, so whenever you have that situation, you will use this one. Okay. Just change the curve from y equals to fx to x equals to fy. So at least we will be getting dx by dy equals to 0. Okay, so this is how you can proceed whenever you have this situation. Okay, because if you proceed in dy by dx, you can't solve it. Okay. Now the next we will come to the parametric form.
Excuse me, ma'am. Ma'am, in the numerator, there should be d square x by dy square.
Yes,
Yeah,
ma'am. The
y2,
second
y2.
derivative
Yes,
is
it's a y2. I made the
x2.
mistake. It's a y2, no? The second derivative. Yeah, you're right. Sorry. d2x by d2y. Okay. So now we will come to the parametric equation. So parametric equation means we will express y and x in terms of another parameter. Okay, like y of t and x of t. So the equation of the curve will be x equals to xt and y equals to yt. Okay. Y equals to yt and t is the parameter. So in this case, what happens here? So we have simply we will substitute there. Okay. We will have dx, dy by dx will be dy by dt by dx by dt. Okay. So here if you have dy by dx, so what we do is dy by dt by dx by dt. So let's write this way. Okay, y dot by x dot. Okay. Dot stands, we are doing the derivative with respect to t. Okay, then we have the second degree. Okay, so what will be here? The second degree, again we will differentiate with respect to d by dx of y dot by x dot. Okay, and here it will be d by dt. So now you can proceed. So what will be the equation here? 1 by x dot will come from dt by dx. Okay, and then you can go for the general. So 1 by x dot, and here we have minus x. Your double dot means we will do the derivative with respect to t twice, and in the denominator we have x dot square plus y dot square, x dot square. Okay, now you will substitute in the curvature formula. Okay, so what we will have, the curvature will be this one in the numerator. So we will have and in the numerator we have so here you have the formula. So at least one simple, you have the circle, you can try for the circle. What is the curvature? What is the curvature? Circle, or let's consider that parabola x. What will be the for the parabola, the standard form, the parametric form?
Y square equal to 4ax.
Y square equals to 4ax. So what we do, we should write. You can put x as t and y as
X is t square and y x is
280.
8t square and y equal to 280.
so you put it and what you are getting? So there will be many equations. Okay, directly also you can put it. So you have to find the derivative for x and y, and then double derivative also with respect to t. Okay, okay, then I'm writing the proper
Ma'am,
formula. Yes, yes.
ma'am, can you please explain the last part and how do you do that equation from the previous step?
I just substituted
No,
here.
ma'am,
This
in
is
the parametric equation.
here.
Yes, ma'am.
This one.
Yes, ma'am. The
This
denominator
is
was
y2.
x dot cube.
This is d2y by dx square, and k is how much? K is y2 by 1 plus y1 square 3 by 2. So this is what I have substituted. Okay. So this is y2.
Yes, ma'am.
Okay. And 1 plus y1 is this one, y dot by x dot.
Yes,
You are not getting after substitution? Okay.
ma'am, I'm
So,
getting now.
okay. So this is y2 and y1 you have to substitute. Okay. Then in the polar form. Okay. We'll do later. Okay.
Ma'am,
Let me write the yes.
ma'am, can you scroll up to the value of k, the first?
This one. And we
Yes, ma'am.
consider the positive value. Okay.
No, ma'am. When you multiply d alpha by dx and dx by ds,
Yeah.
ma'am, dx by ds should be under root
You
1
said
plus y1 square.
this is dx by
Okay.
dx. This
Okay,
one.
ma'am. Okay.
Okay. So it is dx by dx. So we did 1 by. Normally we don't know, but here we are considering the inverse and we are writing like this.
Ma'am, what we call dx by dx?
Dx by ds, this one. Nothing.
Yes.
It's simply we go for the inverse of this one. It's the rate of change of this arc length with respect to this x-axis. Okay. So now we will come to the polar form.
And that is coming minus 1 by 2a whole into t square minus a whole to the power 3 by 2.
2a is, could you repeat?
Minus of 1 by 2a into t square minus 1 whole to the power 3 by 2.
Okay. Okay. I suppose you have done properly. And one thing we will go for the positive values. Okay.
Okay,
The
ma'am.
curvature. Okay. Okay, now the polar form also the same. Okay, but here we have we have r and theta form here. Okay, so here polar form we have x. R is given in terms of r equals to f of theta. This is the form. So we have r and theta form here. And the polar coordinates are given by x equals to, we have constant here, r cos theta and y as r sin theta. Okay. So if you look at the curvature K here, so here R1 will be dr by d theta and R2 will be second order derivative. Okay. Then if you substitute there, okay, directly I'm writing here. R square minus 2R1 square minus R1 R2 and we divide it by R2 square plus R1 power 3 by 2. So this is in the polar form, the curvature. Okay. Then we also have circle of curvature and radius of curvature. Okay. So we have three forms. Okay. Normal standard form, we have Cartesian form, we have parametric form and polar form. And all three forms we have the curvature here. So you can find curvature of circle. What is the curvature of circle? Both way you have the forms. The standard you consider. Okay, I didn't give you anything. Just a general form if you are able to find curvature of the circle, like we did for the straight line. So what is the curvature of circle? Let's say what I will give you. X as a cos theta and y as a sin theta. We have the right. Let's write here r. Okay, so that we can have it in a form. R cos theta, r sin theta. Okay. So what will be the curvature here? All three forms you can use. You know the Cartesian form also, the equation of the circle. So what is the curvature you are getting? Any of you done? Whichever way you find, you do it. Not that you will be using this polar form, parametric form, or you can also use this one also, the Cartesian form one. This is R2. Sorry, this one is R square plus 2R1 square minus R2 by R square plus R1 square. So what is any of you got it?
Yes, ma'am, it is coming 1 by a sin square theta minus cos square theta whole to the power 3 by 2.
This much?
Yeah, I have got.
So R square and R1 will be any other answers? So this R1 will be dr by d theta. R is under root x square plus y square. So you did it with parametric form or the polar form?
Yeah, I did it by parametric form.
Okay. Any other answers? Okay, what was your answer? You say R is
1 by a. Ma'am, what R?
sorry K.
Okay.
Which
Whole into my a whole into. Ma'am, total not total in a in denominator.
okay.
1 by a sin square theta minus cos square theta whole to the power 3 by 2. This what is going.
A not or
Any other answers or this is the answer?
And pi by 2 root 2 r.
K is pi by 2.
2 root 2r.
This much. Anything else? Let's try here. So what will be y1? 2x plus 2y, y1 equals to 0. So y1 will be minus x by y. Okay. So what will be y2 now? I'm just trying. Okay. You let me know if I'm making any mistake. Plus 2 y1 into y1 and y into y2. Am I right?
Yes,
You
ma'am.
just let me know if I'm doing any mistake. Then y dot y2. So what if we will have the value of y2, then we can do right. So here 1 y2 will be 1 minus y1 square divided by y. I made any mistake, then you just tell me. Minus 1, I think. Minus 1 minus y square. Okay. So and y1 is minus x by y plus x by y and divided by y. So it will be y minus x or x minus y. See, I don't know. You just try and put it. Okay, now if you substitute in k, this is y2 divided by 1 minus y1 square, 1 minus or 1 plus, even I don't remember. And it's 3 by 2. Okay. So here if you substitute, this is x minus y divided by y square, and this is y1
y2
is
is
x.
equals to minus 1 by minus y1 whole square. Then ma'am, that x by y should also be in that square.
Yes, okay, you're right. So this will be y square, x square minus y square, and here we have y cube. Is it? I made mistake. X square minus y square by y cube.
Yes, ma'am.
So x square minus
No,
y square
that
by y.
that will also be minus ma'am. That in front of minus x square by y square.
Here,
Because y1 is minus x by y and we are squaring the whole term.
okay. So then minus 2. It's important, right? If you miss the sign and we are not going to get it. Because for the uh, circle, we try to find one generalized form. Okay. So then here also minus. Minus you can take out. So now here this is minus x by y. Again 1 plus x squared by y squared, and we have 3 by 2. Okay. So what we are getting, let's try minus x square plus y square. And here we have y square plus x square 3 by 2. And for y square, let's make it here y square into 3 by 2. It will go up. So this one will get cancelled, right? 2, 2. And this one. And what we have? We are getting r. So we are getting minus 1 by r. Is it coming minus 1 by r? But this minus should be absorbed somewhere. Or we are going for the positive value. 1 by r. 1 by r is the curvature of circle. Okay. So either we will go for the positive value, that's right. But whether I made some mistake with the minus sign. So here minus 1 minus y1 square. So curvature
Just
will
will
be
become
1
minus 1
by
by
r.
r.
So this curvature of circle is 1 by r. Okay. It's constant, right? You see, because it's a constant that you also know. Okay. Because every time you see it's its location, the definition of circle says that. Okay. It's a constant bending. It bends everywhere, and that is with a constant one. And that's not the same for ellipse or any kind of curve. Only for the circle, it's constant everywhere. The curvature is. Okay. So it is 1 by r. Okay. So we go for the positive value. So that I said. Okay. So we will go for the positive value. Okay, you can try for this part also. I think some mistake because you should be getting the same whether you go for polar form or parametric form. Okay. So curvature we done, then we will do the circle of curvature and radius of curvature. Only the formulas we will discuss. Then we will do some more problems. Okay. So it's time. Okay, I'm ending the class.
Ma'am,
Yes.
ma'am,
Yeah, I can hear you. Say.
ma'am. Since the circle has curvature constant, so ma'am, circle has a curvature, so
Circle curvature is not constant. At every point you are getting constant curvature. What it? I mean,
yes,
1
ma'am.
by
Yes,
r.
ma'am.
Every point your curvature is 1 by r. Okay, curvature constant the same thing. Okay,
Ma'am,
okay, I got it.
ma'am. So if we take any 2 points in the circle and find k average, it will also come one by r.
K average.
Yes, ma'am. Between any 2 points in a circle.
No, between any 2 points of a circle, you find the curvature. Curvature we find at a given point. Okay.
Ma'am, since it's constant, then it should come
Oh,
the same,
any
na?
point if you find it will come 1 by r. At 2 points, any point.
No, ma'am, between any 2 points.
But curvature we don't
And
find at any 2 point. Curvature means we find the how much it is bending that at that particular point. At a given point we find curvature. We don't find at 2 points. Okay. At a given point we find the curvature. That means how much bending is there at that particular point. It gives you
okay.
what it. We don't find at 2 points. Okay, that is a curve. See how we approach. We have a curve, and when b approaches to a, that is the limiting value we did for the curvature. Okay. Next we have radius of curvature. Okay. Any doubt or we will discuss in the next class?
Excuse me, ma'am.
Yes.
Ma'am, if we have some doubts in some problems after the class, then where should we ask that?
Okay, we will put some time. Okay. In the class, if you have started doing from Jain anger, there are many problems. Okay. You
Okay, ma'am.
do exercise. There are many exercise, and their hint is also there. I think I didn't know way back.
Ma'am, in the last, the answers are given. I mean, at the last of the chapter, at the back of
Only
the
the
chapter.
answer or hint is also
Ma'am,
there.
some answers are also given, and for some typical question, the hints are also given.
Okay, okay then. In
Ma'am,
the
still,
Ramanna book exercise, many exercise, but in each and every question, they will give you the answer and hint. That is very good to practice. If you have, okay, I will get that exercises from the Ramanna and upload. Okay.
ma'am, still, if we have some doubts, then where should we ask that?
Here only class you was.
Okay, ma'am.
But actually it will take a lot of time, right, for the individual doubts. Okay. So you try post. We will find otherwise sometime. Okay. Because suppose all 5 doubts will come, then five like one class will go. That is the thing. But try to come up. Okay. You should not like you if you have you are solving and you are getting doubt where like in the finding the derivative. It's not the doubt. Okay, that doubt you have to do. You have to find out the derivative integrations. Those I am not going to say. But if you have some conceptual doubts, then you come up, or you try to message me. Okay, you
Ma'am,
message me if I have time, or we will get one particular doubt class.
so where should we post the message?
Yeah, you message me in my phone Or you put it in the classroom also. I will see. That is better. You put it in the classroom, and the question also you put it, okay, and your part of solution, where at what stage your doubt. 3 things you will be putting, okay. Just take a snapshot and put it. Got it?
In the classroom, ma'am.
You will put it in the classroom. I will see there. No problem.
Okay, ma'am.
And if you think some concept doubts, you can message me also in my phone.
Ma'am, I don't
Why
have
I
your,
want, because yes,
actually I don't have your phone number, ma'am.
my phone number. I think all of you should have. You keep it. Okay. Okay, I'm putting it my number. But not all of you will message. I told you. Okay. What you have to do is some conceptual doubt. Then you will message me in my phone. Otherwise, you put it in your classroom. My phone will be, I'm teaching 3 classes, so you think about that. But all of
Ma'am,
you
I will.
have my number, okay?
Yes, ma'am. I will share
This
that
is
in
my
the
number.
class chat.
I said, okay. How you can get it from your friend also. You got it? You don't get the concepts, or you have so much doubt is there, then you try to message me. Otherwise, post it in classroom. I will see. Okay. Doesn't matter. I will see the classroom also. But you have my number.
Okay,
Okay
ma'am.
then. Okay then, I'm ending the class. It's already time.
Thank you, ma'am.
Thank you,
And
ma'am.
and,
No,
and
thank you, ma'am.
from the
Thank you,
next
ma'am.
week. Okay, from the no, your class is in time. Okay, I forgot to tell the other students. Okay, it's okay. Okay, I'm leaving.